In this video, we will solve 2 or 3 problems on continuity. So this is the first problem where they have given f of x as x plus 2, that is if x is less than or equal to 1, and x minus 2 if x is greater than 1. Now, how to solve this? See, every polynomial function, it's a continuous function in their given intervals. So if I consider the interval x less than or equal to 1, x plus 2, it will be a continuous function. And if in the interval x greater than 1, we say that x minus 2 is a polynomial function, and hence in that interval it will be a continuous function. So now we have to see like at which point this function's value is changing. Actually, we can say it is for 1, right? For less than 1, it has one value. For greater than 1, it has different value for f of x. So we will check the continuity for at that particular point x is equal to 1. So we can say f of 1, that is equal to, see, x less than or equal to 1. For x is equal to 1, it is this function x plus 2. So I will substitute 1 in this equation. So it will be 1 plus 2, that will be equal to 3. So if I consider the left hand limit, so if I consider 1, okay, you have your 0, minus 1 and 2, 3, right? So if I am approaching this one from left hand side, I will consider this as left hand limit, and from this side I will consider this as right hand limit. And left hand limit, it is given by limit x tending to 1 minus, because the 1 is a point here, so 1 minus f of x. Okay, so for that it is less than or equal to 1. This is the equation for that. So I will consider x plus 2 limit x tending to 1 minus. So here I will substitute 1. X is equal to 1 because it's for the point 1, right? So 1 plus 2, that is 3. And next consider the right hand limit, that is equal to limit x tending to 1 plus f of x, that is equal to limit. So this is the right hand limit. We can say this equation x minus 2. So 1 minus 2, that will be equal to minus 1. So from this we can say left hand limit is not equal to the right hand limit, and hence this function is not continuous at x is equal to 1. It is continuous for the interval x less than 1, and it is continuous for the interval x greater than 1, but at x is equal to 1, this function becomes discontinuous. And when you consider this, f of x is equal to x plus 2 minus x plus 2. So x plus 2 is for x less than 0 interval, and minus x plus 2 is for the interval x greater than 0. So x less than 0 is x plus 2, right? But this is for x greater than 0. But at x is equal to 0, what is the value of the function? It is not defined. So function f of x is said to be continuous if it satisfies the 3 conditions. That first, it should be defined at x is equal to a. So f of a should be defined, okay? Then it should be having the limit of the function as x approaches a. And the third condition is this should be equal to f of a. Then only I can say the function f of x is continuous. But here the function is not defined at x is equal to 0. The function, it becomes discontinuous at x is equal to 0. But for this interval, this is continuous. For x greater than 0, this is continuous, because these are the polynomial functions, and you know that the polynomial function is a continuous function. Okay. Next, let us consider another one. F of x is equal to sin x. F of x is equal to sin x. Is this a continuous function? Yes, obviously it is a continuous function, because you know how to draw that, right? So I can draw this graph without lifting my pen. So this function is continuous. Okay. But how to prove it? So I will consider one point. See, and at the right side I'll consider it as c minus h, and left side c minus h, right side I will consider a point c plus h. So as I'm approaching to c, what happens to this c minus h? Here h becomes 0, right? When h becomes 0, this value becomes c. So this is left hand limit, this is the right hand limit. So left hand limit will be limit x approaching c minus f of x. Right hand will be limit x approaching c plus f of x. And this is c. So at this point you will be having f of c. So f of c will be equal to sin c. Okay. Now I have to check the left hand limit and the right hand limit at this particular point. So you can see, so for the simplification purpose, just remember this c minus, okay, c minus h. Okay, so x I will be replacing by c minus h, f of c minus h. But here what happens? C minus h becomes c when h approaches 0, right? H approaches 0. This one will be your left hand limit. Right hand limit, that will be f of c. For simplification purpose, remember c plus, so c plus h. So x is replaced by c plus h. And it becomes equal to c plus h, it becomes c when h approaches 0. Okay, so find the value of these two. So f of c minus h is nothing but sine of c minus h, right? So limit h approaching 0. For this it will be limit h approaches 0 sine of c plus h. So now you have to apply the formula. You know, sin a plus b, that is equal to sin a cos b minus cos a sin b. And sin a minus b, that is equal to, sin a cos b minus cos a sin b. Okay, so now I will apply this formula here. So limit h tending to 0, sin c minus h will be sin c cos h minus cos c sin h. So when h approaches 0, that means cos 0 it will become 1, sin 0 will become 0. So you have, okay, it is equal to sin c. So the left hand limit will be equal to sin c. Similarly, now I will consider the right hand limit RHL. So sin c plus h, right? So I will consider this as plus now. Okay. Once again, if I apply the limit, that is h tending to 0, cos 0 becomes 1. Cos 0 will be equal to 1. Sin 0 will be equal to 0. Okay. So this term becomes 0 and this becomes 1. Okay. So the remaining thing is sin c. So even this is sin c. So now from this you got to know that the left hand limit is equal to right hand limit, that is equal to the point f of c, which is equal to sin c. So I can say the function f of x is continuous.